Okay, so we're going to be solving trig equations, but today we're going to be doing a couple that are a little different. Okay, so we're still going to be following the algebra 2 4-step where get the equation set equal to 0, factor, if you can, set the factors equal to 0, or find the solutions by setting it equal to 0, and then using the unit circle to find our solutions. But today I'm going to do things a little bit differently. So for instance, we have cosine plus sine tangent equals 0. Okay. Now, we've done something like this before in verifying trig identities. Okay. And if I were solving this, I would first have to change tangent using identity and changing it to sine over cosine and then getting common denominators and simplifying it. But there's an easier way. Kind of what we think about is force factoring. Okay. So for instance, if I had the equation x squared plus 4x. Now the greatest common factor is x, but I can, if I want to, factor out x squared. When I factor out x squared, I'm left with 1 plus 4 over x, like this. Because basically when you factor something out, you're in effect dividing both terms by whatever it is that you're factoring out. So in this case, if I factor out x squared, I'm left with 1 plus 4 over x. Okay. Now that is a way of factoring something like this that we have today that helps us out, makes things easier. So for instance, on this problem today, I'm going to factor out cosine. So I'm going to force factor this, and cosine, that gives me 1 plus sine x tangent x over cosine x equals 0. Okay? So basically what I've done is I've force factored out a cosine. Okay? But notice right here, doing that, I end up with sine over cosine, which is in fact tangent. So just so you can kind of see it, we could rewrite this as 1 plus sine x over cosine x times tangent x equals 0. We could rewrite it like that because when you multiply straight across. So this is the same. And we know that sine over cosine is tangent. So in effect, we have cosine x times 1 plus tangent squared x equals 0. Now I have it in factored form, like this. Okay? So set my factors equal to 0. Cosine x equals to 0. And 1 plus tangent squared x equals to 0. And my solutions for this are pi over 2 and 3 pi over 2. And then for this one, I end up getting tangent x is equal to plus or minus the square root of negative 1. Which means from this one, there's no solutions. Okay, because those are imaginary solutions. We can't take the square root of a negative. So that's plus or minus I. So there's no solutions to that one. Now, the other thing we got to look at is, remember, you've got to check your solutions here. Okay, so the problem is that if I plug in pi over 2 or 3 pi over 2 back in here for tangent, tangent of pi over 2 is undefined, and tangent of 3 pi over 2 are undefined, which means these are also not solutions. So for this problem, it's the empty set. There are no solutions to this equation. Okay, so you can't forget to go back and plug in your answers and to check them. Your code for today is L33TM4TH. L33TM4TH. That is your code. All right, now the second one. For this one, the first thing I notice is I see that sine, it has x plus pi inside. Okay, no, you cannot distribute that in. Okay, you can't just, this is not sine, and then you cannot just distribute that in. That does not work. Okay, but this should look familiar. This equation right here, we did that in our last unit. That is our sum identity. Okay, so basically what we're doing here is we're going to be solving and using identity, but this time we're using sine sum identity. And sine sum identity says that sine of A plus B, angle A plus angle B, is sine A cosine B plus cosine A sine B. So just like the last one, kind of using an identity here, but I'm using the sum identity. Okay, so that means x is my angle A and pi is my angle B. So basically this right here, when I use the sum identity, I'm going to get sine x cosine pi plus cosine x sine pi. So that's that part. And then minus what I had originally, minus sine x plus 1 equals 0. Okay. Which means that here I end up with sine x times cosine pi is -1 plus cosine x and sine at pi is 0 minus sine x plus 1 equals 0. And cosine x times 0 is 0. So I'm left with negative sine x minus sine x plus 1 equals 0. So using that identity, I end up with this. And negative sine minus sine is -2 sine x plus 1 equals 0. And now that we have just this one sine, we can solve. So we get sine by itself. Be smart about this. Move the -2 sine to the other side to make it positive. Like that. And basically we're looking for where sine x equals 1/2. And sine is positive in the first and second quadrants, and it's 1/2 at pi over 6 and 5 pi over 6. And if we go back and check our original solutions, these will both work. So these are our two solutions. So first one we force factored. Just make sure that when you do something like that, you check your solutions. And this one we used our sum identity to simplify and solve.